ladies and gentlemen, we have been doing, before break, we did a bunch of stuff with inverse. We are now going to do some stuff with inverse word problems. Okay, remember those inverses? You're going to use those negatives at the top. All right, find to the nearest degree the angle that the sun rays make with the ground when a flagpole 40 feet high casts a shadow of 30 feet long. Okay, so a flagpole is going straight up and down, correct? That's where we get 40. And where would your shadow be? Is your shadow the hypotenuse? Is your shadow along the ground?
It's along the ground.
It's along the ground, yeah. So here's my shadow. That's supposed to be a 90-degree angle. And your shadow is 30 feet long. It wants to find, to the nearest degree, the angle that the sun rays make with the ground. So right here, it's looking for that. So if you can set up your picture, you've got it. Now remember, what is 30? Is 30 my opposite, adjacent, or hypotenuse?
That's adjacent.
Adjacent, because it's right next to it. So across from it, the opposite. So we want to use the inverse tangent of opposite 40 over adjacent 30. And then this is really nice because all I need to do is plug that into my calculator. I hit trig, go down to tangent with a -1, 40 divided by 30, and I get 53 degrees. I'm going to round to the nearest degree. So I know it says 53.13. I'm just going to round to 53 degrees. Okay? Any questions about number 1 before I move on?
Is this how all of them work?
Yep. Okay. Shh. Let's move on to number 2. The top of a 40-foot ladder, which is leaning against a wall, reaches the wall at a point 36 feet from the ground. Find to the nearest degree the angle that the ladder makes with the wall. Okay, so when I make a ladder, guys, is ladder going to be straight up and down? Is it going to be along the ground? Is it going to be the hypotenuse? So that's my ladder. Shh. My ladder slants. And it's against a wall. And it says, which is leaning against a wall, reaches the wall at a point 36 feet from the ground. So I'm 36 feet above the ground, right? And it wants to know, find to the nearest degree, the angle that the ladder makes with the wall. So this is where the ladder is with the floor, so that's where it makes with the wall. Okay, so 36, is that my opposite, adjacent, or hypotenuse? Opposite, adjacent, or hypotenuse is 36.
Oh, I thought you
Adjacent, it's right next to the x. See,
why is it?
okay, let's talk about this because this is one of the most common mess ups. Shh. If we look here at this triangle, see how the x is the bottom? So 40 is across from it, it's opposite. Robert, I really wish you'd pay attention. If I have this x right here, see, it's right next to it. I've moved my x. My x is no longer down here, it's up here. It all depends on where the x is, whether it's the opposite or adjacent. Because it said find to the nearest degree the angle where it makes with the wall.
Oh.
Okay. And so 40 is my, try again, hypotenuse, right? It's across from that 90 degrees, it's usually the slanted one. Okay? So if I've got adjacent and hypotenuse, remember I've got my SOHCAHTOA. Which one? Sine, cosine, or tangent uses adjacent. You guys got to be quiet. Cosine. So cosine, inverse cosine, adjacent over hypotenuse. So I'm going to put that in my calculator. Shh. You got to be quiet while I'm teaching. You know I'm going to give you time to work on homework where you can talk. But you got to be quiet while I'm teaching. I get 26 degrees. Okay? So I feel like that was a little confusing because we moved that x from the bottom to the top and we had to figure out what adjacent and hypotenuse and opposite were. Okay, let's look at 3. An isosceles triangle has side lengths of 5, 5, and 6. Find the measure to the nearest degree of each angle of the triangle. Hint, drawn altitude. Okay, first of all, what does an isosceles triangle look like? 2 sides are the same, right? So if we've got an isosceles, we know this side is 5, and this side is 6. What else you need to know about an isosceles is these two angles right here, they'll be the same. Okay? Now it says to draw an altitude because we do not have a right triangle here. But if I drop an altitude right here, okay, I've now cut this side in half, but I've made 90 degrees. Everybody okay so far?
Yeah.
Okay, now I'm going to have to do this one twice because I need to find both angles. First, I'm going to find this angle down here. So if I'm looking at this angle down here, 3 is my opposite, adjacent, or hypotenuse. I split 6 in half when I cut it. Adjacent, good. And 5 is my hypotenuse. Okay, so I'm going to use inverse cosine, adjacent 3 over hypotenuse 5. So I'm going to hit the inverse cosine button.
Can you turn on the brightness?
Yeah.
It's going to be the same for the other side.
3 divided by 5, yep. So this is 53 degrees. Now we need to find this up here. Well, the nice thing about this is, what do the interior angles of a triangle all add up to be? 180. So I'm going to do 180 minus 90 minus 53.
So that's 43.
It's 37. So y is 37, but y is only this part. I want the whole thing. How am I going to find the whole thing?
Oh, you said minus 53?
Yeah, because that's what that is. So I'm going to double it. So I'm going to go 37 times 2, and I get 74 degrees. So I get 253 degrees and 174. I took 37 and I times it by 2 because 37 is only, please be, this is my last problem.
That's half of it.
That's just half of this.
Okay.
So if I times it by 2, I get the whole. Okay? So I highly recommend you doing the other ones in class. I want to point out, because I get this question all the time, Miss Murphy, how am I going to do this at home? Well, if I bring up my calculator on my phone and I turn it sideways, it comes up and I've got the sine, cosine, tangent right here. If I push the second button, all of a sudden my inverses come up. So if I do like 3 divided by 5 equals, and then I hit inverse cosine, it should come up. Well, oh, it's not in degrees. Okay. So it needs to be in degrees, though, to be able to do it. But it will come up. Okay? So you need to do these on the back for your homework, and you should be in pretty good shape.
Well, the first one was